Are you tired of spending hours trying to debug your code? Do you wish there was a better way to find those tricky bugs? Well, get ready to take your debugging skill to the next level. In this video, I'm going to show you how to travel while debugging. Yes, you heard it right, time travel. With this advanced debugging technique, you can go back in time and inspect your program's complete state at any point of time. Not only that, but you can also use the full range of debugger functionalities to navigate both forward and backward throughout your code. Okay, say goodbye to tedious restart and frustrating iterations. But that's not all. I'll also show you how to use reverse watch points to track when and how a variable or memory location was last changed. And I will teach you also how to navigate throughout the program execution history in a way that simply aren't possible with the conventional debuggers. Trust me, your debugging skill will never be the same again. So make sure to hit the subscribe button, press the bell icon, and get ready to travel through time with Programming Gyan. Okay, so before we'll start debugging our code, let's have a brief look what it is, what is the code we are going to debug. So let me start with main. So we have three threads in main. Two threads are running this thread function 1 and one thread is running this thread function 2, and after that we join these three threads in this main function, so that main thread will wait till these three functions completes its work. In thread function 1, it's pretty simple. We have a kind of infinite loop and we are taking a lock on our mutex, then we are doing some calculation and we are printing value of I, and then we are doing some calculation with g value, and that's all. Okay, and g value is a global variable in this program. Now in thread function 2, again we have an infinite loop and then we are doing some calculation and printing the value of I and incrementing g value by 1. Pretty simple, right? Now let's see. So what we'll do here is first we'll have to compile our code. I had already compiled in this system, so I'm using my previous history. Okay, so it's compiled and let's check. We have race.cpp and we have race our binary. Now here I'll be debugging this application using a debugger which is very advanced, I'll say, and it's called UDB. It has all the functionality which GDB has, but it has some extra advantages which are missing in GDB. Or if you will try to simulate those things, then you will need a couple of extra tools and all those things. So that we'll see later on in some video. Okay, so I'll clear my screen and let me run this binary under UDB environment. Okay, so our UDB environment is set. Now let's run this application, and oh, it looks like we got an assert at this point, and it's showing that that assertion is that this condition is not true and it failed. Okay, so what to do? So first thing, because it crashed, so we can check the call stack. Let's check the backtrace. Okay, so we have this backtrace and you can see everything. Okay, here is the our application code where it actually crashed, where this crash started. Okay, now in traditional debugging, you will have to now rerun this, you will have to put some breakpoints and all those tedious things you will have to do. But with this UDB, what we'll do here is we'll run one command, reverse finish. Okay, what this reverse finish will do is it will travel back, it will execute, means it will go a step back, go to the place where your last function was called. So if you see, we are going one by one back, and if you are not able to visualize it in this, just have some patience. I'll show you how it is going back. Okay, and now another thing is you need not to write the command every time. Now last command we executed was reverse finish, so if I simply hit enter, it will execute the previous whatever the last command I executed. Okay, now I came in at the place from where my application started crashing, from where that crash started. Okay, here tip: you can press Ctrl X A and you will get a TUI, terminal user interface, and in the first upper section you will see the code, your application code, and in the second section, this lower section, you can run all your debugging commands. Okay, so let me show you how you can go step one by one. So now I'll run another command, reverse next, and if I hit reverse next, you will see this execution point came to line number 43. I'll hit again and it will go back, again it will go back. And if I from here, if I want to go forward, I can simply say next, it will come next. Okay, looks interesting. Yeah, it is. Okay, so here let's see what are the values of the local variables, info locals. So you can see all the values. Old value has value this, a is this, I is this. You can see all those things. So now understand this code. We got this assert because this C value was not equals to old value plus a. So let's see some code near here what exactly it is. So if you see here is what it is doing is it's storing this G value as an old value, and it's calculating getting some random integer number as a, and at line number 43 where this code is incrementing this G value by a, and it's checking G value equals to old value plus a, old value plus a. Ideally this should be same, right? But there is something happened and this condition, this assert got failed. So let's watch. So let's see. Okay, at this point our old value is 922 and a is 5, so ideally G value should be here 4052927. Okay, let's check the G value. So to see the value of means G value, what it contains, we have this command print G value, and it has something different. Okay, 935. So there is something happened in between. Someone changed this G value. Consider this is a very big code base, and if you want to see who changed this G value, what you will have to do is you will have to put lots of logs. One way is that, or you will put if you have any debugger, so you will put lots of debug point and you will see what is happening there where. But here with this UDB and with this advanced time travel debugging technique, what you can do is you can now what I'll do is I'll just run through this command, this execution. Okay, so what I did, I executed this UGO end, so it's completed the execution in the forward direction. And now what I'll do here is what is the command? Last, I want to check who changed this G value. So the command which I'll run is last G value. So it will tell us where exactly this G value got changed last time. Okay, and if you see, last it got incremented here. Okay, and because of this increment, our G value got changed, right? And when before this was calculated, someone changed this G value. So this is the thread, this is the another thread which executed this G value +1, and we do not have any mutex or anything here. So this creates a data race in our application. It's a clear case of missynchronization. Now we got the place where exactly it changed, and let me reverse. So rn is the command or shortcut for reverse next. So if you see here, it's again change this G value. So sorry, G value, it changed here. So if you see, if you observe, this thread is executing and it's changing. So let's watch this G value throughout. Okay, so whenever this G value will change, it will print this. If you have this means if you want to continuously watch when this G value is getting changed, you can run this command watch G value, and whenever this value will change, it will print. Okay, you can see here. Okay, 37. Okay, one thing, because we are reversing back, we are executing backward, so you will see the previous value first and then the previous -1 afterward. Okay. Okay, you saw this execution went. Let's run this. Okay, so before it came here, it executed again. Okay, now this line got executed. Okay, so before this line gets executed, it came here and it's executed. We will do next, and it crashed because that thread got started. Okay, hope you understood how easy it is to debug with time travel debugging technique. It's only single iteration I did. I executed this binary only once, right? And I found the issue, where exactly the issue is, which code piece is changing the value unintentional value change which code piece is doing, we found in a single iteration. So I'll suggest you guys to go ahead and try this time travel debugging technique, and it will be helpful for you to debug, and it will definitely save you lots of time and iterations. And I understand, I have 12 plus years of experience, and I understand that pain when you are debugging such critical issues, and if you miss that debug point, it becomes very frustrating to restart from the beginning. But that means thankfully we have this kind of technology and tool where we don't have to frustrate. Okay, so having said that, if you learn something new and you definitely like this video, please like this video and share this with your fellow programmers, and don't forget to subscribe.